final review. So for the first one, we're going to describe the transformation from the parent function. Now, if we look, anything inside either a parentheses or a radical with x is going to be my h. Remember that x lies. So this is h is equal to positive 2. So if your h is positive 2, that means we're going in the right direction too. And then we look at our k. K is outside of the parentheses or radical. That's going to be a positive 3. So if k is a positive 3, that means we're going vertical, which is up 3. If we look at the next one, what is the equation for this graph? Remember, your parent functions always start from the origin. So we're just going to say my parent function is this one. So assuming that our a value does not change, we're really just looking at the vertical and horizontal changes. So let's go from this point of inflection to this point. So we're going to go right 1, 2, 3, 4, 5. So we're going right 5. That means my h is going to be equal to positive 5. And in my equation, it's actually going to be negative 5. Remember that x lies. Then we're going to look at our k. Our k is our vertical change. So we're going to go down. My k is equal to negative 5. And that k will be on the outside. So the equation for my transform function is y is equal to square root of x minus 5 minus 5. Let's look at this next problem. We have a square root function. Now for the parent function, it's going to be the same as this one here. So notice that my a is equal to 6. That one is going to create a vertical stretch. Your h is 0. Notice how there's nothing inside the radical. So there is no horizontal change. But there is a change at my k. My k is negative 1. That means we're going to go down 1. So if we look at the parent function for a square root goes from 0 to infinity. That's for my domain. And for the range, it's also from 0 to infinity. But because we went down 1, that means that's going to change my range down 1. So the range for this new function is going to be negative 1 to infinity. And because there's no horizontal change, my domain stays the same at 0 to positive infinity. Let's move on to the next one. Describe the transformation from the parent function. Again, my parent function is the square root of x. So anything that is different from the basic square root of x is what's going to give us our transformations. So first, we're going to look at this negative. That negative is going to reflect. And this year we did not talk about any horizontal changes, so there will be no reflection across the y-axis. Next, we look at the 1/4. Because the 1/4 is smaller than 1, and that means we have a vertical compression. Remember that x lies. 3 is inside the radical with the x, so that means my h is equal to negative 3, and that tells us it's going to left shift 3. And then this negative 5 is going to be my k, and k doesn't lie, so we're going to go downshift 5. Moving on to the next one, we're going to be solving cube root equations. So in order for us to solve, we need to isolate whatever we're getting the cube root of, which is this expression, and it's already isolated. So the next thing that we need to do is get rid of that cube root, which means we're going to cube both sides. This cube root cancels the cube, and we get 3x is equal to 3 to the third power is 27. Divide by 3, and x is equal to 9. Let's solve the next one. This is already isolated. This whole thing is getting this, we're getting the cubed root of this whole thing. So because it's already isolated, we can cube both sides. The cube root cancels the cube. We get x minus 2 is equal to 64. And then we're going to add 2. And x is equal to 66. Moving on to the next problem. We're going to solve this one. Notice how this equation, your radical is not isolated. So what's keeping us from having it isolated is this 4. It's being added. So we're going to subtract the 4 from both sides. We get -2, and now that the radical is isolated, we can cube both sides. The cube root cancels this cube. And then -2 to the third power is -8. And now we can solve for x by adding 6. And x is equal to -2. For the next example, isolating the cubed root. It's already isolated, so all we have to do is cube both sides. This one, we're going to solve square root equations. My square root is already isolated, so in this case, we're squaring. Square root cancels the square. 6 squared is 36, and we get x is equal to 12 because we divide by 3. Next one, notice how both of them are getting the square root. We're getting the square root of both expressions on both sides of the equation, so we can square both sides, and the square root cancels the square. And then because we have a squared, if you remember the rule, if we have a squared, we always want to make it equal to 0. The equation equal to 0. So that means we're going to subtract x from both sides. That's going to cancel that one. And then we're going to subtract 4 from both sides. Combine like terms, we get x squared. We can add where we only have one x combined. And then we can combine -2 and -4. That gives us -6. We have it equal to 0. And then from here, because we have squared and we have 3 terms, this is where we want to use our a, b, and c. And we have -6 in the top, -1 on the bottom, 6 and 1, that doesn't work. 3 and 2, that works. We need the negative to be with the 3. So then we have x minus 3, x plus 2. And then we said each one equal to 0. X is equal to +3, and x is equal to -2. So both of those will give us the same solution. So these are our two solutions. All right, let's move on to the next one. We're going to solve this square root. The square root on the left side is already isolated, so let's go ahead and square both sides. These cancel. We get 2x plus 8 equals x squared. Again, we have an x squared, which means we need to make it equal to 0. Since my x squared is already positive on this side, I'm going to move the 2x to the right side and the -8 to the right side. And that gives us an equation where it's equal to 0. And once it's equal to 0, we can solve. We have 3 terms. We have x squared. We can use our ABC. And we can use our shortcut on this one also because my coefficient of x squared is 1. So we've got -8, -2 on the bottom. The factors of 8, remember we need to subtract. So we get 1 and 8, those don't subtract. 4 and 2 subtract to give you 2. We need the 4 to be negative. So we have x minus 4, x plus 2. Now 4 is 4, so 4 is a true solution. And now let's check for negative 2. So we've got 2 times negative 2 plus 8 equals negative 2. These give us square root of, this is 4. Negative 4 plus 8, square root of 4 is equal to negative 2, and 2 is not equal to negative 2, so x equals negative 2 is an extraneous solution. Remember, you could type this into your calculator and you can get whether it is a true or false statement. Let's look at the next one. Notice how this one is not isolated, the square root. So we're going to subtract 5 first. Square root of 4 minus x is equal to 3. Now that it's isolated, we can square both sides. We get 4 minus x is equal to 9. We want to subtract 4. Negative x is equal to positive 5. We cannot have an x as a negative. The variable can't be negative when we solve, so there's like a negative 1 here. So we're basically dividing by negative 1, and x is equal to negative 5. Now we want to check if it's an extraneous solution or negative 5 is a true solution. For the next one, we're going to be adding and subtracting polynomials. Because there is a plus sign, we can drop the parentheses and just combine like terms. Okay, when we subtract, we're basically subtracting everything inside the second group. So it's going to change all of the signs. So you can think of it as negative 1 times 6. Negative 1 times negative 2x is positive 2x, becomes negative 4x cubed, and this becomes a positive x squared. And then we're going to combine like terms again. 2x cubed minus 4x cubed, that is negative 2x cubed. We're going to multiply. So we do first term times first term using the FOIL method for double distributive. So this is 5x cubed. This is plus 10x squared. And this is minus 15x. We've got negative 4x squared minus 8x positive 12. And notice how I lined it up with its like term. So our answer is 5x cubed plus 6x squared minus 23x plus 12, if my math is correct. Okay, and the last example, we've got negative 2x cubed plus 9x squared minus 5x